Okay, once again, good afternoon, students. First of all, let me clear that earlier we have discussed the three important temperature measuring devices, that is resistance temperature detector RTD, thermistors, and thermocouples. And RTD is popularly abbreviated as resistance temperature detector is popularly abbreviated as RTD, and thermocouples are also abbreviated as TC, that is thermocouple. This class is very important because today we are going to compare the performance of these three devices, which is having a common objective, that is measurement of temperature, but there are certain parameters on which they differ to each other. So we'll discuss some parameters one by one. So let us see what are these parameters. First, we will discuss about the type of transducer. It means which type of transducer is RTD, thermistor, and thermocouple. Then we will discuss about the material for the construction. Which kind of material is used for different transducers like RTD, thermistor, and thermocouples. Then we will see about the range of temperature, because all three devices are having a common objective for the measurement of temperature, but their operating range for the temperature is somehow different, right? And looking to the range of temperature, they are having a different applications even, right? Then we will see the working principle. Although the RTD and thermistor, they are based on same principle, but the concept behind the working of thermocouple is different. Then we will see the physical appearance, how physically these devices are available in the market with some popular products. I will show you some pictures of these devices which are available in the market. Then we will see the mathematical relationship. We have individually in different lectures of RTD, thermistor, and thermocouple, we have seen the mathematical relationship for all these three devices. Today, in combined form, we will see what is the difference between these devices. Number 7 point is related to the characteristics and symbol. How these devices are represented by different symbols and what are these characteristics, right? Then we will discuss about the accuracy, its sensitivity, then speed of response, how they respond towards their characteristics, right? Then we will also discuss about their cost, and finally we conclude our lecture with the discussion on the different applications on which these devices are used. Okay, so one by one we'll discuss these points. Number one is type of transducer. As we have already discussed, the RTD and thermistor both are passive devices. Passive means they need some kind of supply or current source or voltage source for their operation. But thermocouple is an active device. It does not require any kind of supply for its operation, right? This is the first point. Second point is material. Although we have individually discussed, but today we are going to discuss in combined form. RTD is normally made up of a single metal, or you can say conductor, right? Most usually it is made up by platinum, and it is also known as PRDT, where P stands for platinum and RTD stands for resistance temperature detector, right? Thermistors, if we talk about the material for the thermistor, we know that these are usually made up by semiconductor materials and the metal oxides. The examples are manganese, cobalt, and nickel oxides, right? As far as thermocouple is concerned, yesterday in our class we have seen that it is made up of two dissimilar materials having different temperature coefficients, right? And one of the most popular example is iron and constantan. Number third is range of temperature. We have seen that the RTD, or you can say that is platinum RTD, which is used from up to the range of 1000 degrees centigrade, whereas thermistors are having low range, or you can say lowest range, up to 300 degrees centigrade, whereas we can use the thermocouple up to 2000 degrees centigrades, right? So thermocouple is having highest range of operation and finds lot of application, particularly in industries, right? If we talk about the working principle, as I have already mentioned, RTD and thermistor both are based on the same concept of change in resistance with respect to temperature, right? Whereas the thermocouple is based on thermoelectric effect, or you can say Seebeck effect, where we make use of two materials having different temperature coefficients and joined together. Then some kind of EMF is produced, right? Next point is physical appearance with propeller product. This slide show you some pictures. These are related to the RTD, right? One popular material in this regard is available in market is PT100, which and its range of operation of voltage is also shown here, right? Here PT100, also PT1000 is available in the market, where PT100 represents 100 represents the resistance value at reference temperature. Means PT100 is having 100 ohm at 0 degree centigrade, whereas PT1000 is having 1000 ohm at 0 degree centigrade, right? This slide is related to the physical appearance of thermistors, right? The most popular device which is available in the market is LM35 along with its operational voltage requirement. Also DS18B20 is also available in the market. These are the commercial product related to the thermistors, right? And these two products are related to the thermocouples. Also K-type and some I-type materials are also available in the market. Recently, for the application of solar energy, we have purchased these I-type of thermocouples. As far as their mathematical relationship is concerned, this relationship, the top one is related to the RTD. If we use some kind of linear approximation, then we make use of R equal to R naught 1 plus alpha delta T, right? Where alpha is your temperature coefficient of the material. If you talk about thermistor, then resistance RT is equal to R naught e to the power beta, and again temperature difference in reverse format, where beta is the constant depend upon the type of material, and the range of beta is usually varies from 2000 to 4000. And the last expression is related to the thermocouple, where again C1, C2 are the coefficients related to the material. Again, if we consider some kind of linear approximation, then again the term related to the square term, that is non-linear term, we can neglect it, right? This is the very most important characteristics, where you can see the symbol of RTD along with RTD, thermistor and thermocouple, their symbols and their characteristics. Here you can see that the RTD is having most linear characteristics, whereas thermocouple is having a non-linear and thermistor is having exponential characteristics. If we talk about the accuracy, then the most accurate device among these three is RTD. Its accuracy range is 0.1 to 1 degree centigrade. It is the most accurate device, right? And somehow thermocouples is having the lowest accuracy, varies from 0.5 to 5 degrees centigrade. It depends upon the combination of materials used. If you talk about the sensitivity, again RTD is having the better accuracy as compared to thermistor and thermocouple, right? Next one is speed of response, or you can say thermal response. Here you can see that the response of thermistors is highest. It is the most sensitive device and having fast response as compared to RTD and thermocouple. This slide is basically showing the typical range of their thermal performance. Next is cost wise. If we compare, then RTD is slightly expensive and thermocouples are the most cheaper among these three devices. And the last point and the most important point
सर
is,
आपका नेट गया है.
right, RTD, it is used for air conditioning, plastic processing and microelectronics applications, whereas thermistors is mainly used for the temperature compensation. As we know that most of the thermistors are having negative temperature coefficients, so it is mainly used in the networks for circuit protection, their control and temperature compensation, right? Whereas thermocouple, it is mainly used for the application where we want the temperature at a particular point, right? In case of solar, this finds lot of application and industries like rocket engines, fog machines, etc. This device finds lot of applications. So here we have discussed lot of points. So I think most of you have understood. In our next class, we will come with some different topic.